MS Sawan and Shivaji University, Kolhapur. So what is my content here? That is relevance, literature review, research graph, the problem background, the definitions, whatever workflow, and the conclusion and references. So our topic is that, sir, that is designing of the specifically hybrid optimization model to efficient design of digital filters. That is, as we know that today the ECG signal is the very important parameters in COVID situations. So now what I will do, that is ECG signals can be rewrite as or reoriented, that is removing noise of the signals from that to get the accurate information about that. As everyone knows that the digital signal processing is the signals that can be specifically designed for the frequency response of that signals that is modified and reshaped according to the desired specifications. Now, what should be the meaning of filtrations? So that is in medical signal processing to control and use that particularly outstanding performance of that particularly flexibility of that filters. That is nothing but say as in-time domain amplitude and phase response, as well as the best parts to follow the specifically system delay. So that can be performing easy optimization, high performance of the filter, a linear phase filters, always stable filter, delay resources, and feed forwards. So these are the basic concept required to design that particularly FR filters or any one filter design. But I'm using three different types of the algorithms. That is nothing but say stochastic algorithm that can be easily used for the particle software optimization, genetic algorithm, and differential evaluation. I have combined these three algorithms to design an independent or a specifically model to design that particularly for the high frequency as well as the specific frequency working over the ECG signals itself. Now I have done some literature survey over there that can be found from the slide number, that is literature survey review, that is development of the methodology to stable and efficient robustness design of the PSO. So what that indicates that PSO is affecting indirectly on the amplitude of the signals, that is magnitude of the signals. Then the GA, that is genetic algorithm, is processing working on that particularly digital filters types, better magnitude as well as the phase response. And the differential evaluation that can be working for that is relevance of the delay over specifically that is system delay and signal to noise ratio over there. So these are the some 2-3 slides that can be objective what we have research pending. That is means we found that is only the filters are affecting on amplitude, magnitude of the response, then phase response of the filters, then the system delay and the signal to noise ratio. So what I found from the research graph, that is if we working for the GA, PSO and DA, the PSO is nothing but say it is affecting on that is nothing but say the amplitude of the response. That factor some have that is a convergence speeds that is depending on the initialization, recombination and initialization of the factors. Then ZA is the that is nothing but say converting bonds that is can be working for the crossover, wavelet mutations and some ripples found in the passband and stop bands over there. And the last one, that is DA, is nothing but say parallel competition of the increasing that is diversity of that minimum magnitude with ripples and passband in and stop band also. Now, as we found that is effect on frequency response, effect on convergence speed, affecting on magnitude of the digital filters and affecting on the system delay as well as the signal noise. So the frequency response, this particularly problems can be affecting on that the optimization algorithm face following problems. That is first one, the frequency response, second one, reduced system delay, third one, the filter distortion, and fourth one is the order of the filters. Now I have designed some workflow, that is design of digital filter first of all, then design of optimization algorithm over there, then input bit stream means ECG signal is applied to the evolutionary hybrid model. That is whatever I have designed the independent hybrid model for that. Then simulation of that particular hybrid model, then analysis over software as well as the practical implementation and some expected result over there. Now what should be the method should be the user in the find earlier best algorithm first of all. Then second is nothing but set that particular best algorithm to the specific value, that is algorithm. Then set it is a best cost with global optimizations. Then we will find out that is a multi-rate parameters, means we can use the any one parameter from that. Then correlate that particular characteristic and find the errors to get the next generations. Now the next one point is nothing but say flow of characteristic of hybrid models, means a flow chart over there, that is initialize, first of all, whatever the parameters over there in the ECG signals. Then by using PSO as well as the DE, we can find the best parameter, that is P based from the PSO and the P based from the DE. Then we know that roulette wheel is there. So best possible conditions, we can move that particular wheel in around 360 degree. Whatever the best possible conditions we will find from the roulette wheel. Then we will go to the P based is less than, that is the G based. It is G based is there, that is a global based, and P based is nothing but say personal based. That particularly reaches to this particularly global based. If it is yes, then go to the G based is equal to P based, means that new P based we will be found over there. If no, then you will go to the next iteration and we will continue till the we will get the next next P based or G based value over there. If iteration is over, then we will find out that is stop that particular iterations. Now, what should be the hybrid model outputs? If you use the ECG signals, normal signals we have used, then we can add in that some noise over there, or whatever the noise present in the ECG signals. We can't predict it that is P, Q, R, S, T. As we know that ECG signals, that is a P signals, Q signals, R, S, T. So from that, we cannot be predict it is a specific DCGs coming from that. So because of that, I have just used that particularly removing of the noise by using some filters over the designs, by using combination of 3 algorithms over there. Now we will get the filter output, that is hybrid models. We'll find out that is a filter hybrid output over there. Now what we have expected and what we have achieved, as we know that number of iteration is the very important parameters. In previously, that is whatever the particle swarm optimization, genetic algorithm, and differential evaluations, if you see, more than 500 iterations are there. But whatever I have designed independent, that is hybrid models, that requires only the 50 iterations to work that particular problems, to solve this particular, to clear this particular noise from that. The second one is nothing but say processing delay. As we know that the processing delay is nothing but a requirement of that time execution of that particular program. As we have seen, that is 120 seconds, 135 seconds, and 175 seconds required for the particularly PSO, GA, and DE. But my independent, that is nothing but say work from in 110 seconds only. The next one, as we know that the amplitude of the, that is sensitivity of the digital filters, as we know that it is in minus 100 dB for the PSO, it is minus 167 dB in GA, and differential evaluation it is minus 232 dB. But I have designed that is it is a minus 348 dB, that is independent hybrid algorithm. And the last one, that is nothing but a signal to noise ratio. As we know that better performance, so that is nothing but in dB. As in particle swarm optimization, it is 2.8 minus 2.8. It is in genetic algorithm, it is 1.71 dB. In case of differential evaluation, it is 1.60 dB. But I have designed it for 202.51 dB in the signal to noise ratio. I have concluded with this particularly. So hybrid optimization algorithm is designed for very less performing in accuracy in more noise. That is as we removing the noise from that particular system, that is reduced the system delay by using the algorithm, also better shows the performance. The third one, hybrid optimization magnitude and phase response is better matching with respect to the order performance, and signal to noise ratio, that is PSO, D, and G, greater the signal to noise ratio as compared with the other one. So I have some analysis over there. So these are the 4 parameters I have done, that is number of iteration, processing delay, magnitude response, and signal to noise ratio. The whatever I have independently, hybrid model of optimization is better as compared with the previous one. So it is better performance in all these particular references provided to that particularly signals. So these are the references, some books as well as the research papers. Thank you. That's it from my side, sir. Any questions?
Thank you for your wonderful presentation. Wanted to understand with respect to your conclusions basically and recommendations. How good is your research with respect to other type of technology rather than hybrid? So because I couldn't able to see your, I mean, your like three slides are showing up, and it is so unable to read also me properly. So I wanted you to tell me how good is your proposing with respect to the current technology. That's the only thing I would like to ask.
Yes, sir. Yeah, if we see the number of iterations, right, sir?
Yes. No, 1200. Okay.
Yeah, if you see the number of iterations, so in case of hybrid, I have designed only for 50 iterations. If you rest of them, if you will take, that is PSO, GA, and DE, that is red color is nothing but say PSO, yellow color is nothing but say GA, and the violet color is nothing but say differential evaluation. So my hybrid is the first one. It is very less iterations. So
Okay.
as we know that less iteration is meaning that is it's working for the very good high iteration, that is only for 50 iterations only. If you rest of them, it is 500, 800 or 1000 iterations are there. Second one thing, that is a processing delay. I have done only in 110 seconds, sir, as compared with the other three, that is 120, 135 and 175 seconds are there required for the execution of this particularly finding out the ECG correct signals over there. And the third one, that is the amplitude sensitivity, means as we know that it is a minus 340 dB, that is magnitude response for the hybrid one, as rest of them it is minus 100 dB, minus 167 dB and minus 230. But I have designed for it is a minus 348 dB itself only.
Okay.
And then,
So,
yeah.
like compared to other 2-3 things, you have designed what are the disadvantages and advantages with respect to 2 things you are telling.
Yeah,
okay.
yes.
Okay, good. So